to create an awareness for the students on the upcoming trend on achieving carbon neutrality. In this context, today, I'd like to start the second day of our workshop by introducing our esteemed speaker for the day, Dr. Ramesh Babu sir. He is currently working in he is an associate professor in Satyabama Institute of Science and Technology from the Department of EEE, and he specializes in power electronics. He has a vast experience in this field, and especially in the field of electronics. And today he is going to share us on the topic of concept of electric vehicles and its challenges. He has researched and published over more than 40 high impact factor journal articles. It's an honor to have you here, sir, today with us.
Thank you.
So for today's meeting, today's workshop, the proceedings for this will be like sir will present his topic for 45 minutes. That is around till 6:20, and we leave the panel for the students or the audience for questions for the last 5 minutes. Okay, sir. With this, I hand over the session to you, sir. And we can
Thank
start.
you.
Thank you.
Thank you, Ashwin. Thank you for good introduction about me. Thank you.
Thank you, sir. And you can start, sir. Proceed, sir. Okay, thanks.
So, first of all, I would like to welcome the participants for the 5 days virtual workshop on achieving carbon neutrality using green vehicle. Okay, myself Ramesh Babu from Department of EEE, School of Electrical and Electronics. Today my topic is going to be, today is day 2. My topic is going to be concept of electric vehicle and its challenges. Okay, so first we'll discuss about what is an electric vehicle, what are the types of electric vehicles are there, okay, what are the configurations are already is available, that we'll discuss on that first. Then we'll discuss on the sources, what are the sources may be there, energy sources may be there, and what type of motors are going to be used for the electric vehicle. Okay, and then what are the charging technology which will be available. After discussing these all those things, then what are the challenges are there for making an electric vehicle? What are the challenges are there? That we'll discuss today. Okay, so I'll move on to the first slide. My slide is visible to you?
Yes, sir. It's visible, sir.
Yes, sir. Please proceed.
Yes. Yeah. Okay. Okay. So first is why we need to go to electric vehicle. We have a IC engine, right? So why we wanted to go to electric vehicle, right? So in the world, you can see largest source of the greenhouse gases emission because of the human activity. The 3 activity, namely you can call it. One is nothing but burning of fuel for production of the electrical power, electricity, production of the electricity. Next, there will be a heat which may be generated from cooler or maybe some other appliance, right? And then transportation. These are the 3 human activity. Due to that, largest source of greenhouse gases which has been emitted to the environment. Okay, so these greenhouse gases which will be emitted to the atmosphere, which is going to make global warming, which causes the rising of the sea level, climatic changes, and disturbance of the animal natural environment, extreme weather. Okay, these are the negative sides of the emission of the carbon in the atmosphere. Okay, so this is because of 3 mainly human activity, that is called production of the electricity. This is we are producing electricity mainly for thermal power plant. Okay, so this I'm indicating for mainly for thermal power plant and for the heat and then transportation. So my topics today is going to be transportation. Due to the transportation, there will be a carbon footprint will be there in the atmosphere. It is making that atmosphere will be a very musty atmosphere. To avoid that, what are the steps can be taken, right? So what the transportation side, we are going to convert electric vehicle, right? So the electric vehicle helps to reduce the transportation threat. Okay, so we have a 3 threat. In this, I'm going to take for the transportation threat. Okay, next, The e-vehicle also may be charged with the help of the grid only. If you charge again the grid, again the environment will be polluted. If you charge the electric vehicle with the help of the renewable sources as like solar, so that emission still it's better, it reduces, right? So why we want an electric vehicle? A transportation, mainly for a transportation emission, right? Next slide is going to be what is electric vehicle. So this is what a pictorial representation, how the carbon footprint may be there in the environment, right? Next, what is an electric vehicle? A vehicle may be powered partially or fully, then it is nothing but electric vehicle. Electric vehicle is nothing but the vehicle which is powered by partially or maybe fully is powered is nothing but electrical power, then it is nothing but electric vehicle. Okay. Normally, why people are going for an electric vehicle? Nowadays, you can see in two-wheeler, most of the two-wheelers are electric vehicle has come nowadays. Why? Because of the rise in the petrol and diesel rate, right? So that is why people are also going for a four-wheeler, also planning to go for an electric vehicle. But the problem is charging station. That is a very big challenge for the electric vehicle to charge. But two-wheeler charging in the home, we'll be doing a whole night, nearly for 6 to 8 hours we are charging, right? But car for charging is, it may take some more time still, but still more. So due to that only people are hesitate to buy an electric car, right? So that's going to avoid it if the charging stations are came to the India, so it will be avoided. Okay. So why people are going for an electric vehicle? It's a running cost will be low first. Running cost is low, and then it have less moving part. If moving parts are lesser, maintenance is less, right? And then it's a very friendly environment. Emission, very, very smaller emission or no emission. Smaller emission is nothing but if you use both hybrid, then you have a small emission in there. If only pure electrical propulsion system, if we use no emission, right? So this is what an electric vehicle, some picture of the electric vehicle, which I have shown here. Here you can see main parts of the electric vehicle here for traction motor. First is nothing but a traction motor, and then battery, and then power converter and controller, okay, and battery management system. These are the main parts of the electric vehicle system. One is nothing but traction motor, and then battery, and then power converter, and then controller, then battery management system. So these are the main parts of the electric vehicle system, right? We'll see one by one, right? See that picture I have shown in the blocks diagram. That's like the blocks diagram I have shown here, right? Okay, so you can see. So I'm going to use a DC motor as a traction motor. Okay, in the C here you can see is a DC motor. This is a DC motor. I'm going to use a traction motor. So if it is a DC motor, I need to get the input is a DC supply. There will be electrical supply. There will be two types of electrical supply, AC and DC. In our homes, we will be using all the appliances are AC supply. Here, if we use as a DC motor as a traction motor, you need to have DC, variable DC as an input for the DC motor. To get variable DC, we need to have a DC to DC converter. Okay, and there is a controller. Okay. So the battery which provide constant DC volt, it never give variable DC. It provides a constant DC volt. That constant DC voltage may be converted into variable DC voltage with the help of the converter, power converter. Okay. How much you want to convert? Suppose the example from the battery, if I am getting as an 48 volt DC, that 48 volt DC, I wanted to convert into 110 volt DC. Boost to get a boost voltage. Okay, so I need to go by DC to DC boost converter, whether maybe 100 volt or maybe 80 volt or 45 volt, whatever may be. To get that, I need to get accelerator properly. If it is accelerator, that means that controller, it may be a controller, it deciding the controller. The controller, it decides how much voltage needs to be provided to the DC motor. Okay. So main part here we have discussing like battery, power converter, controller, and motor. Okay. So how the battery is going to be charged? Here I have shown two ways to charge. One is nothing but grid charging, EB charging. There be EB supply is AC supply, which is converted to DC with the help of the rectifier, and it is charged to the battery. This is grid charging or EB charging, right? Or you can also do it through the renewable sources, as like solar, right? So the solar is a solar energy which will be converted as a variable DC, then it will be charged to the battery. Okay. So this is nothing but an DC system. Because I'm using as a DC motor, I need to have a DC supply to operate as a DC motor. Okay, it is a DC system based electric vehicle. Similar way, I can have a AC based electric vehicle. There will be only one different will get. So from the battery, I'm using DC to DC converter. If I use, instead of the DC to DC converter, I can use DC to AC converter. I can use AC motor. Right, that is nothing but AC system, electric vehicle with AC system. Okay, there I can use any kind of AC motor, maybe induction motor, AC motor like this. Okay, so switched reluctance motor, SRM motor, or synchronous reluctance motor, any kind of motor I can use that. Okay, so there will be a two system. One is nothing, but it is decided based on the motor which you are going to use. If you use the DC motor, it's a DC system. If it is AC motor, AC system, right? So this is what a AC system, which I have explained just now. So other system remains same, right? Next, I'm going to the types of the electric vehicle. So what are the types of electric vehicles are there? Mainly. So first is nothing but a battery operated vehicle. Next, hybrid electric vehicle. Next, plug-in hybrid electric vehicle and fuel cell electric vehicle. These are the four types of electric vehicles are available, right? So one by one we'll see. What is battery operated electric vehicle? The main source here is available, energy source which is available only is the battery, no other sources. Battery is the only source which is available here. Then it's called a battery electric vehicle. So this vehicle, I can say that emission will be very little because I am using only energy source as a battery as a source I'm going to use. Okay, and these types of vehicle, the range it may be for 100 kilometer to 250 kilometer basic model maybe. Some higher end model I can get that 300 kilometer to 500 kilometer for a higher end model. So anyway, range which can be a factor that how you drive the vehicle. Some people, they will drive a two-wheeler, you can see in the roadside, right? So keep on, they will put a brake, right? So driving style, it is also affect the range. And where you drive, highways, urban road, uphill, based on the road also, road condition of the road, driving style, climate, battery age, these are also going to affect the range of the vehicle. Okay, so the problem of battery operated vehicle, only battery is the source which is available. If the battery is dry, then no other source is available. That's the drawback for using this kind of battery electric vehicle. So the battery vehicle, the picture I have shown here, right? Next is nothing but hybrid electric vehicle. So from the name, you can say hybrid. What do you mean? That two systems, electric propulsion system, mechanical propulsion system. Two systems are available. Okay, electric propulsion system also available, mechanical propulsion system also available. But main driving is it's based on the IC engine, mechanical propulsion system only. So where you have power demand will be more, in that place the electric system also, electric propulsion system also will come and play on that. Okay, so if it is required, Okay, so that instant electric propulsion system also come into play. Otherwise, the main source is here is nothing but mechanical propulsion system. It's nothing but IC engine. Okay, internal combustion engine which will be used. Okay. And how the battery is stored. See, this hybrid electric vehicle system may be based on the operation. It is classified different modes actually. I'll show you the mode. You can see in the starting. You can see from the diagram starting. IC engine is working. Okay, IC engine started and working. It is going to give a power to the driven wheel. Driven wheel is getting a power from the IC engine. At the same time, battery is charging. The diagram you can see this diagram, first diagram starting. Okay, and then passing mode. What do you mean by passing mode? In this mode, driven wheel gets the power from IC engine, at the same time battery. Electrical propulsion system. So mechanical propulsion system, electrical propulsion system, both is going to give a power to the driven wheel. This is nothing but passing mode, right? Next, braking. Braking mode. At the time of braking mode, power is taken from the driven wheel and it is converted into electrical power with the help of electric motor. Here, the electric motor is working as an electrical generator and is charging the battery. Okay, it's charging the battery. So charging of the battery in two ways. One is nothing but at the time of start, we are charging the battery. At the time of applying a brake, we are charging the battery. Okay. And cruising mode, in this mode, IC engine is going to give a power to the driven wheel. At the same time, it is going to give a power to the battery. Okay. So the mechanical energy is converted to electrical energy with the help of the motor. Here, the motor is acting as a generator. You can ask how the motor will act as a generator, sir. It's based on the input. See, a DC motor is nothing but as a DC machine actually. It's a machine. Which input you are going to give? Based on that, it will operate. It's a DC machine. Here, I'm going to give electrical energy as an input, then it is a motor. It is getting electrical energy, it is going to provide mechanical energy as an output. If I am going to give a mechanical energy as an input, it is going to operate as a generator. Yes, input is mechanical energy, output is electrical energy. So based on the input which you are going to provide, based on that, the machine is going to operate, right? So here, the hybrid electric vehicle, the problem is the battery is charged two-way. One is at the time of starting, at the time of braking. Only this instant, the battery is going to be charged. Grid charging is not at all possible. Grid charging is not at all possible here, right? So this is what a hybrid electric vehicle. So here you have two propulsion systems, electric propulsion system, mechanical propulsion system. Both propulsion systems are available. Next, plug-in hybrid electric vehicle. From the name, you can see plug-in, right? So battery may be stored. Battery maybe gets the power from the grid also. At the same time, you can get the power from the braking. Okay, so the battery is going to get the power in a two-way, through the grid or through the braking system. Two ways the battery is going to energized. Battery is going to get the power, energy, right? But the problem here, main source, here the main is nothing but electrical propulsion system is the main source. IC engine is called upon once the demand is more. The previous case, hybrid electric vehicle system, mechanical propulsion is the main source. Electrical propulsion is the additional one. Here, electrical propulsion is the main source. Mechanical propulsion is the additional one. Because it can charge, battery can charge with the help of the grid also. But that facility is not there for a hybrid electric vehicle. That will be available for a plug-in hybrid electric vehicle system. So the plug-in hybrid electric system, you can see that the carbon footprint will be eliminated. Emission of the carbon will be lesser, very lesser when compared to the hybrid electric vehicle system, right? So this is the diagram, historical diagram, which I haven't shown here. And the last one is nothing but fuel cell electric vehicle system. Okay. So the fuel cell electric vehicle system nowadays, it's going to be very boom actually, fuel cell system, because its initial cost will be very, very high when compared to the all other system. Fuel cell system is cost will be very, very high, but it will be very good actually. Source we are going to use here, there's nothing but as hydrogen is a fuel we're going to use here, right? So we are going to get a hydrogen and oxygen from the outside and going to generate electricity. And what is the byproduct we are going to get here, right? So the oxidation process, the electrons may be generated, okay? The electricity may be generated. The generated electricity is going to drive a driven wheel. It will be applied to the driven wheel. So the excess of the power which can be used for the charging of the battery, okay? So this is what on fuel cell electric. You can also call it as hydrogen fuel cell vehicle. Why? Because here the fuel is hydrogen, so it will also call it as hydrogen fuel cell vehicles. Actually, commercially many types of vehicles nowadays going to come, right? Toyota, Honda, this kind of vehicles nowadays is going to come for this. So these are the types of the electric vehicle which will be available: battery, hybrid, plug-in hybrid, and fuel cell. These are the 4 basic types of the electric vehicles are available. So the EV configuration. So based on the how it is configured, that is driven wheel, how it is going to get the power. Based on that, it is configured. The electric vehicles are configured. How it is configured? You can see the diagram from that. The first diagram, diagram A, you can see. So basically, you want to know there will be a front wheel driven system, rear wheel driven system. There will be 2 types of driven systems are available. Okay, front wheel driven system, rear wheel driven system. Normally, people are going for front wheel driven system. Okay, front wheel driven system, people are going. Rear wheel driven system also available. Some companies they'll be doing on that also, right? Some specific applications they'll be going for a rear wheel driven system, right? So first one is nothing but front axial or front wheel driven system. Here you can see there is a motor and clutch, gearbox, and your differential. So other things are all you know very well, right? A motor is going to get a mechanical power and clutch, and then is a gearbox, and there is a differential. So what is the use of the differential here? That's the main thing actually. So differential, if you want to operate at a different speed of the wheel, suppose right side and left side 2 wheels are there, both the wheel can be operated at a different speed. For that, a differential may be used. Okay. Okay. So this is what the first technique, configuration. First configuration. There, motor will be there, clutch will be there, gearbox will be there, and your differential, which is be available. Right. And second case, you can see motor, there's no clutch. Fixed gearbox. It is called as fixed gearbox and differential. Some automated cars and all in this way, right? Motor, fixed gearbox, and differential. This is second type of configuration. And third type of configuration, you can see same way in the axle, front axle, it is fitted. So transmission is reduces here. The transmission systems reduces, losses may be reduces, right? Motor, fixed gearbox, and there is a differential, right? It will be fixed in the front axle itself, right? This is nothing but on third configuration. And fourth configuration, we are going to eliminate differential. What is the function of the differential? It is going to provide different speed for both wheels, right? So when you bend in the, when you bend in the roadside and all, you can see that both wheels are operating in different speeds, right? So for that, a differential may be mainly used. So if you remove the differential, what happens? You need to use different motors in each wheel. That is what the concept which has been used next configuration. Fixed gear motor for one wheel in the front axial, left side wheel, right side wheel like that. And again motor fixed gear. That will be used for next right side wheel, right? So if you remove the differential, you may reduce this way, right? And this is on a fourth configuration. And then there is a fifth configuration, motor, and there is a rotor itself. Rotor setup will be used for the driven wheel system. Okay. And for a fifth and sixth category, it will be nearly same. right? So these are the configurations are available. In this configuration, there will be two types of normally people are going: in-wheel drive system, all-wheel drive system. Okay, people are normally nowadays is going. The research also going in this techniques: in-wheel drive system, all-wheel drive system. Apple, they have used some car system. I think if time permit, I'll show the video also. The Apple, the car which is going to be coming to the market, that I'll show you. If I time permit, I'll show the video also, right? Okay. So there you have a all-wheel drive system, in-wheel drive system. These are the concept that we use there, right? So next, what do you mean by all-wheel drive system? As I told you, there will be a two driven. One is nothing but front wheel or rear wheel. If we use both front wheel driven as well as the back rear wheel driven, if you use, then it is nothing but all-wheel driven system, right? You got my point? So it's a more control and power will be there. But the problem of using this, I'm using a motors for front axle, rear axle. Both side I'm using. So what happens? It's a costlier weight. Okay, weight of the vehicle will be more, right? So the all-wheel driven system is nothing but motor. The traction motor will be used for front axle as well as the rear axle. Both sides it is used. You can see the diagram. Red color it is mentioned is nothing but front motor and rear motor. Red color other side right motor. It will be fixed your axle wheel, rear axial as well as the front axle. Okay. So in this case, two motors may be used, front and rear, to provide the better traction in the slippery condition it will be used, right? So next is nothing but in-wheel drive system. Okay. So in the in-wheel drive system, you can see the motor configuration in the in-wheel drive system. As we discussed the previous diagram, you can see this is what a in-wheel, last one is nothing but F, that's nothing but in-wheel drive system, right? So in the in-wheel drive system, see, motors are connected. Central motor, they also provide more control. In the wheel itself, the motor has to be connected. Wheel itself, motor is connected. But the problem here is the power supply which is given to the motor, cabling, with the help of the cabling, it may be done. So it is not safe. Why? Because when it is harsh environment or vibration and acceleration, this purpose, it is causing a series of trouble in this type of vehicle, in-wheel driven system vehicle. Okay. But this system quite convenient for parking and all, very, very easy actually, this kind of vehicle. Okay. So the people are going for this in-wheel drive system. But the wires which will be connected, power line wire which is connected to the motor, that will be a trouble. That may be safety way. If you do that, this in-wheel drive system is better than the all-driven system. Next is nothing but a general block diagram. General block diagram of the electric charge system. So general block diagram, here we are going to discuss energy sources first. What are the types of energy sources are available? Next, what are the types of motors are available? Propulsion system. Next, we are going to discuss what are the charging techniques which may be available. So these are the things we are going to discuss from this block diagram. First, we'll discuss about the energy sources. What are the types of energy sources are there? Where you can use this kind of energy sources. What kind of places you can use this energy sources? Okay, that we'll discuss now. So energy sources, we can get the energy record from the different sources. Many different sources are available. Get the energy. So to get energy, you can say that as a battery or maybe a fuel cell or maybe ultra capacitor or maybe a fuel cell, like many energy sources may be available. From that, we are going to get energy to operate a traction motor. So it is based on the two parameters. One is nothing but specified energy and specified power. Okay. The specific energy, you can say it's a specific energy, specific power. If you're talking about the energy, it means that a range. If you are talking about the energy, then it's nothing but range. What do you mean by range? Range is nothing but this much kilometer is covered, this water range. Okay. If you are talking about the power, specific power, it is going to increase the acceleration, going to increase an acceleration. So the energy, specific energy means that as like on your range. Specific power is the range, is nothing but acceleration. So these two parameters we need to keep in your mind. Based on that, you have to select the energy source. Where you want to use your vehicle, what energy you want, whether you want a specific energy or specific power, then based on that, you have to select the energy sources. Right. The first energy source I'm going to discuss is nothing but battery. Okay. So batteries have major energy source. Most of the vehicle, 90% of the vehicle nowadays have a battery as the energy source which can be used, right? So in the battery also there will be a different battery technology which will be available, right? Lead acid battery, lithium ion battery, nickel cadmium battery. These kind of many batteries are available, right? So in vehicle normally now the people are going for a lithium ion battery. Nowadays, lithium ion battery, they will be going on that. Okay, people are going for a lithium ion battery. Nowadays, other battery in the lithium also, some other range of the other variety of the battery also nowadays is coming. Right. Normally now people are going for a lithium ion battery for the electric vehicle application that people are going. Some predominant battery types which has been given: lead acid, nickel cadmium, lithium zinc, and lithium ion batteries. These are the batteries. So there will be different battery types are there. Each one have their own advantage and disadvantages are there. Each battery they have their own advantage and disadvantages are there. So lithium ion batteries are normally we will be using. It is a mature technology. Mature technology. Lead acid batteries is a mature technology, but lithium ion going to replace that. Why? Because it's environmental healthy, provide us a healthy environmental, so that people are going for a lithium ion. And also here challenging is while using in the battery system, reproducibility. How to use reuse your battery? How to reuse your battery? That is a challenging factor here. The people are going research on that, doing a research based on that only. How to reuse our battery? That is also going. At the same time, here we wanted to say many cells are connected. Based on that, many cells are connected serial and parallel as like an PV system. As your requirement, 48 volt, 36 volt, 110 volt, whatever the voltage you record, that can be used here. Okay. Here we need to maintain the SOC level of the each cell, state of charge, SOC level. How much it can, maximum how much. Based on that, the ratio is nothing but SOC, right? So based on that, so we need to select the battery. Next is nothing but ultra capacitor. Another energy source is nothing but ultra capacitor. So there will be a positive electrode, negative electrode in between a dielectric media, right? If you apply a potential across that, there will be a positive answer accumulated and negative answer accumulated, right? It will be a charging. Charge, electrostatic charge. It's nothing but electrostatic charging. Electrostatic charging. It is maybe charged. So this kind of ultra capacitor, where it is used, it have, as I told you before, battery is nothing but going to provide a specific energy. That means that if you want to increase the range of the vehicle, I can use the energy sources of battery. If you want to increase the acceleration, I need to go by specific power. That means ultra capacitor. So that is the best choice, perfect choice for that is an ultra capacitor. So where you want acceleration more, during the acceleration are conditions like hill climb, high power is required in the short duration. For short duration, where you want a high power required. That instant, you may need to go for an ultra capacitor as an energy source. You need to go, right? It is also fast capturing energy at the time of regenerative braking. It also captures the energy. very faster way it captures the energy. So it means that it fast way captures the energy, at the same way it releases the energy in the faster way. So ultra capacitor is the first choice, it's the best choice for the specific power. That means that high acceleration. Next, fuel cell system. So fuel cell system, normally already we have discussed about that also. Fuel cell system also normally we are going for a specific energy. That means that range, you want to increase the range, you can go for a fuel cell system. Okay, these are the energy sources as we have discussed. Okay, and one more energy source also will be available, thermal energy storage system, that we are not at all going in that. Okay, some other speaker they are going to cover that topic, right? And so I have energy sources: battery, ultra capacitor, and fuel cell. These are the energy source systems are maybe available. So today my topic is the motor. About the motor, I wanted to give more idea. in the motors. Initially, we will be used for the DC motor. Nowadays, we are not at all using DC motor right now. Why? But the DC motor is the best choice for the high starting torque, at the same time wide range of speed control. These two applications, people are going for a DC motor. Okay, but it's a poor choice for electric vehicle operation. Why? Because in the DC motor, the drawbacks for using drive motor, it's a maintenance problem of maintenance. There will be a commutation. This maybe occur, carbon brush and commutation will be there. So due to that, sparking may occur in this motor. Okay, maintenance also. You need to maintain neatly. It's need a maintenance. Okay. So due to that, we are not at all going for a DC motor control technique. But the DC motor is the best choice for wide range of speed control, high starting torque. In the traction application and all, we'll be going for a series motor only. DC series motor or AC series motor, the kind of motors people are going. But the problem of not using is maintenance and sparking occur. And also you can see noisy, bulky. It's a noisy and bulky. Due to that, people are not going for a DC motor. So the picture, first the left side, for my left side, the picture which has given here is the DC motor, armature, stationary mode, magnet, electromagnets are there, right? The commutator, that's a problem of commutator. What do you mean by commutator? Why it is used here? It is going to convert, produce as a AC, but we want a DC. Okay. So the DC supply, whatever the supply which is given, the AC, which has to be converted to DC, or if you keep providing a DC, it can be converted to AC. While you're doing a conversion process, there is a commutation sparking has occur here, right? And next motor is nothing but brushed DC motor, permanent magnet. Instead of the electromagnet, if I use the permanent magnet, okay, losses may be reduces maybe, but higher rating you cannot go. If you use permanent magnet, you cannot go for a higher rating at all, right? So permanent magnet, again it's a brushed. Again, maintenance problem is occur, right? So in this previous diagram, you can see instead of that electromagnet, if you use permanent magnet, then it is permanent magnet brushed DC motor. And then induction motor. So normally people are going for an induction motor. Normally induction motor nowadays they are going. Why? The induction motor have two types are there. One is nothing but slip ring induction motor and squirrel gauge induction motor. Normally people are going for a squirrel gauge type induction motor. People are going on that. Okay, in this, there will be two types of control techniques are available. One is nothing but a vector control technique. The other one is a field orientation control technique. So with the help of this technique, vector as well as a field orientation control technique, so motor, the induction motor can be act as a DC motor. As I told you, as a DC motor have very good advantage. A wide range of speed control is possible. That application I wanted to incorporate in the induction motor, that is possible only by if you incorporate a field orientation control technique. Okay, if you incorporate the field orientation control technique, so that This may be a DC analog as like a DC motor. The speed of the induction motor also controlled in a wider range. So that the people are going for an induction motor with field orientation control technique. The people are going on that. So this is what the control characteristics which has been drawn between the torque with respect to the speed. These characteristics as well as the vehicle characteristics, you can point straight, it will be better choice for the induction motor. That is why it's a mature technique. It's a mature technique. People are going for induction motor. So this motor is nothing but right side, left side motor is nothing but PMPL DC motor, permanent magnet brushless DC motor. So what are the disadvantages are available in the DC motor? That can be eliminated. There is a equipment or a device which is invented is nothing but permanent magnet brushless DC motor. Okay. Only drawback, as I told you, commutation. So it is a mechanical commutation. If you replace as a mechanical commutation into electronic commutation, then it is nothing but permanent magnet brushless DC motor. Okay. So the people are going induction motor or permanent magnet type motors. The people are going for an electric vehicle application, right? So here, instead of that mechanical commutation, we are going for an electronic commutator. As an inverter may be used. Input DC may be converted into AC. That is applied to the stator winding, and rotor have a permanent magnet. That's nothing but permanent magnet brushless DC motor. Okay. So this kind here also there will be a control techniques, maybe new control techniques, self-control technique, vector control technique. These are the control techniques are incorporated so that the motor may be operated, controlled. Then next one is nothing but the synchronous permanent magnet synchronous motor. So there you want to control the speed of the motor. The frequency, you want to vary the frequency, input frequency. So varying the input frequency, going to control the speed of the synchronous motor. Normally, synchronous motor going to run as a synchronous speed, not at all otherwise. So if I use synchronous motor as an AC motor, the power factor of the system is improved a lot. The power factor of the system is improved. Okay, efficiency is better when compared to the permanent magnet brushless DC motor. Permanent synchronous motor will provide better power factor while going using this technique. And then the last one is nothing but switched reluctance motor. The switched reluctance motor is nothing but, you can see, it's nothing but as like a stepper motor, you know very well, right? A stepper motor concept. Switched reluctance motor is nothing but it's a stepper motor concept. It's a force of attraction between the two magnets. Force of attraction. Okay. The stator have a coil and rotor doesn't have a coil, right? So stator coils are energized as a force of attraction. The rotor coils are aligned with the stator coils so that motor will start to rotate. This is the concept behind that. But stepper motor, it's a low speed, but high speed stepper motor is nothing but switched reluctance motor. That's all. Switched reluctance motor is nothing but if the stepper motor operated as a high speed, then it is nothing but switched reluctance motor. Other things are working operation characteristics are similar, right? But here the switched reluctance motor, we are not at all using permanent magnet in the rotor side. We will be using on steel like a pole we are using. We are not using a permanent magnet here. This is switched reluctance motor. The final last one is nothing but synchronous reluctance motor. The synchronous reluctance motor is nothing but as similar which we discussed permanent magnet synchronous reluctance motor, but a rotor doesn't have a permanent magnet. Rotor doesn't have a permanent magnet, then it is nothing but synchronous reluctance motor. As like synchronous motor, it will be operating as a synchronous speed or not at all, right? So these are the motors have actually. First one is an DC motor, a permanent magnet brushed DC motor, permanent magnet brushless DC motor, a permanent magnet synchronous motor, switched reluctance motor, and synchronous reluctance motor. These are the 6 types. Out of the 6 types, SRM PLDC motor people are normally going for, or PMSM or PMLD. These are the motor people are going on that. Okay. And then charging method. So basic, there will be two types of charging, AC charging and DC charging. So AC charging is nothing but the AC supply which will be plugged. There will be onboard charger which will be available in the vehicle itself. Okay. So this is what a charging in two-wheeler and all we will be doing, two-wheeler and four-wheeler, those who are charging for the home. These are all nothing but AC charging. Okay. So overnight they will be charging no vehicle, right? Overnight they will be charging. These are all nothing but an AC charging technique, right? Right. So the AC charging, what we will be doing? They will be plugging in the EB supply directly, and AC is connected to our system, right? And the AC, it is converted into DC, and it is charging the battery. So the onboard charger, which will be available in the vehicle, we will be giving AC directly. So the AC is converted into DC, and it is charging the battery. That is nothing but onboard charger, which will be available in the vehicle. This is nothing but AC charging. Okay, but AC charging, if we have more time, it take more time to charge the vehicle. Okay. So in the diagram, you can see any difference you can able to find out. The first diagram, it says that both are variable one. Second time I can see the charging station cable is permanently connected. Third diagram you can see in vehicle cable is connected permanently. Okay, these are the three types normally which will be available, right? In the AC charging station, one is nothing but both are variable, movable, or both can be removed. The second one is nothing but it's permanently connected to the charging station. And third one is nothing but it is permanently connected to the vehicle. Okay. And the next one is nothing but DC charging. So where you want to go, as like Sir has asked before going to start my session, right? Why people are going for a DC charging, right? Fast charging. To charge the battery in a fast way, we are going for a charging. For DC charging system, in the vehicle doesn't have onboard charger because directly we are giving DC supply. There is no need of onboard charging. There is no need of onboard charging, so that you can reduce your weight of the vehicle still. Only battery you can give charging. There is no need of rectifier, charge controller and all. There is no need because directly we are charging as a DC. Okay, and fast charging is possible. Fast charging is possible, but some safety measures you should take. Safety measure you should take for while going for a DC charging system. Right, it's a DC charging station. In this, only one technique which will be available. That is why I told you is safety is very, very important. So permanently connected cable is permanently connected in the charging cable, in the charging station itself. Right. This is the DC charging. So AC charging and DC charging. Next, inductive charging. So induct as it's working on the principle of the transformer principle, mutual induction principle. It is working. Right. So there will be a sending coil, receiving coil. The sending coil power is transmitted. So with the help of the induction principle, the power is received, induced in the receiving coil. With the receiving coil, which will be available in the vehicle. Okay, it's an AC. It's an AC actually. Because induction principle applicable only for AC. So everything is AC. Then again it is converted into DC and is charged. So this vehicle also required onboard charger. Onboard chargers record. This vehicle also onboard chargers record. Why? Because it is an induction principle. It is used. So induction principle applicable only for AC. DC is not applicable. So it will be used that supply voltage, AC voltages will be induced in the receiving coil, and the receiving coil is converted into a DC. Then it is charging the battery. Right. Next is wireless power transfer system. So the wireless power transfer system, there will be a basic type, two types actually. Stationary wireless power transfer and dynamic. In the dynamic also you can see quasi-dynamic wireless power transfer system and dynamic wireless transfer system. Stationary, and it means that a vehicle is parking, vehicle is stationary. Vehicle is stationary, no drivers in the vehicle. You just park on the vehicle so that the vehicle is getting charged. So many industry, In your foreign countries, normally their working office, the vehicle will be charged in this way. When you do parking, so there is no driver, so automatically the vehicle gets charged. And this is on stationary wireless power transfer system. WPT is nothing but wireless power transfer system. Okay. Quasi dynamic, that means that driver is in the vehicle. Vehicle is in go stop mode. What do you mean by go stop mode? The traffic. The vehicles are moving slow.